So let's look at the worksheet now. Have you all done these questions?
Yes.
How was it? Easy, right?
Yes.
Okay, good. Now, the thing about these small assessments, you have to score well if you want to get into a good class. I'm sure you already know what class you want to be streamed into, right? Okay, this is the streaming year. You need to decide what you want to do in future. Okay, if you are thinking of really getting into the pure science class, okay, the first class, right? Then you must make sure you're doing very well for science. You need to secure 80 plus 90 marks all the time. Okay, so how many?
My school only needs to be 3 and above.
Really?
Yeah.
Seriously, to get into the first class?
To get into like pure physics or pure chemistry. Yeah.
But if it's all pure sciences?
It'll still be 3 and above.
Seriously?
Yeah.
Okay. How about the rest of you? Sneha, is yours very difficult to get in?
Mine is like A1.
Must be A1,
Yeah.
right? That's what I know like usually. Haresh, you lucky boy, you. Okay. How about Zenith?
I'm not sure. Teacher never say.
Teacher never say. You can start asking, And then some school also determine the subjects like English, science, and mathematics are the most important. So the first thing they look for is overall score. Okay, so your overall percentage. Then you have to make sure you are doing well in your English, in your mathematics, as well as your science. Is that right, Anaki?
Yes.
You have that also, right? The criteria. Is it A1?
I think A2.
A2, minimum A2. Okay. So Zenith, still not sure, right? Sneha, okay. Sneha, your school says A1. Important to score A1 lah. Okay. Now, correct units for friction, okay, weight, and then pressure. Let's
First
go by
question,
turns.
I didn't know what was the SI unit for friction, but then I just looked at weight and pressure and I found the answer was A. It's very easy.
It's actually quite straightforward also. So long as you know that, friction is actually frictional force. The term force, right, already tells you, okay, the unit has got to be newtons. Okay? So you have to tell yourself, when you see the word friction, okay, so this is actually frictional force. So again, you can also talk about elastic spring force, all right, or elastic force that will also be taking on this unit, okay? So long as you understand they are actually all classified under forces, okay, forces are measured in newtons, you will not go wrong. Is it okay? Can, right, so let's move on. Any question here? No question, Now, which statement about pressure is not true? Okay, so the first one, it says 20 Newton iron bar always exerts the same amount of pressure, okay, as a 20 Newton stone.
No, that's untrue.
It's wrong.
It's wrong, right? So obvious, Why?
Yeah, because both of the bars might have different areas.
Different areas. What is the very important term that you should be using?
Same amount of pressure.
You say they have the same force, right? Pressure is actually calculated by taking force divided by the area. You are referring to this, right?
Yeah.
Yes. So you need to be very, very clear. All right. This is actually implying contact area. Okay. So it's the area in contact. Clear? Can, Haresh? I'm stricter in this sense. You're shaking your head. So strict, this teacher. Yeah, I'm stricter because this will help you to score your marks better. Okay, I'm not looking at your Sec 2 exam only. I'm looking at O level. So when you're at O level, you need to be more specific. Is it okay? So the sharp edge of a knife exerts more pressure. Of course, it will exert more pressure because contact area, okay, contact area is very small. So when you are answering question, it will be good to talk about contact area. Okay. The dull edge of a knife, this one, greater contact area. Okay. Lady wearing a pair of high heel shoes exerts more pressure. We did that last week. We did the calculation. Correct or not? Okay. High heel shoe exerts more pressure because the contact area is very small. And then last one, ski with larger surface area. Enables the skier to slide on the ground easily. Okay. Okay, larger surface area means larger area of contact. All right, so less stress on the feet of the skier. Next one. Which activity below does not rely on atmospheric pressure? This one quite
B.
obvious. Should be the opening a cabinet door. Okay. Do you want me to explain this? Actually, no need, right? Quite obvious. Opening a cabinet door doesn't require atmospheric pressure. Now, this student performs the following experiment. I wanted to do this video, okay, but I realized that actually very simple. You just need to take your, the Coke bottle or mineral water bottle, correct? Okay, you pierce 3 holes at different level. Just look at the diagram, follow exactly. Okay, pour water in, but have these holes tape up first. Okay, you tape up nicely, then you pour water in, then gradually you remove the tapes. You will see that the water will be flowing out at different pressure. You try this, it's very interesting. Okay, the lower it is, the greater the pressure. That also indicates that the deeper you go into a container, the higher the water pressure. Can?
Is D.
Correct. The following action is not possible without, quite clear cannot be heat, cannot be density, cannot be electricity. We are on this topic known as pressure, right? Right, Anaki? Okay. This
Yeah.
trick also, somehow not many students can do it. You don't believe me, you try. Okay, not many students can do it. Haresh, you look like you are not convinced. Later you try. Okay, and then
I did it before. I think I did it before, like in primary 4.
okay, and then it stay on
Yeah,
immediately.
but I mean, I tried this trick before where when you, because of the atmospheric pressure, once you
Correct.
release the cup slowly, the water will not fall out like suddenly like that. It will just stay there.
Yes, correct. Suddenly, but if you can actually do it at one try, that means you have very steady hands. Okay,
Yeah.
actually not that easy. So long as you have a tiny little hole that is not sealed nicely, right? You will never be able to have the paper keep in its place. Okay. Question 6. Elephant weighs 60,000 Newton. All right. It stands on 1 foot. Okay. All right. Then there's this area. So straight away you plug into the formula. Pressure equals to force over area.
That'll be 60,000 pascals. After that, you divide it by 4 because standing on like how many? 1 foot, which is impossible.
Oh, this one is stand on 4 feet. So the area is bigger. Correct? Don't look at the one at the top. This one I'm using 6,000 divide by 0.1, but this is on 1 foot. Now we are talking about 4 feet. So it's actually 60,000 Newton, right? Divide by this area, need to multiply by 4. So this is 0.4 meters squared, right? Zenith, this is correct, right? Okay. Harish, you understand this part?
Yeah.
Okay, so this is the answer. Anaki, do you get this right? Your exam is tomorrow, is it?
Yes. Yeah, I got it right.
So make sure you get it right tomorrow also, huh? Okay, a brick with flat rectangular sides rests on a table. Now, this is a similar question we have tried before. The brick is turned so that it rests on the table on its smaller surface over here. So which row will correctly show how the force and pressure exerted by the brick on the table changed?
It's answer C.
The answer, is it C? Yes, it is C. Okay, because why is it that force remain the same? You are using the same brick. Okay, so maybe I just write down same brick. Pressure is higher because contact area is smaller. Okay, Ken? See how you already took the science exam or not yet? Not yet, but this topic will be tested. So far, all these questions, you are okay? Okay, because force and pressure shouldn't be too difficult. Quite straightforward questions also. All right, next. Bubbles of gas escape from the mud at the bottom of a deep lake. Okay, and it rises to the surface. But then when the bubbles are rising, they become larger and larger. Why is that so?
I think right it's D, because as the surface increases, the water pressure should increase. It's
I
D.
think it's D.
I think it's C.
Oh wait, it's C. C, I got it.
Yeah.
I got it mixed up.
Correct. Because right at the bottom, right? Okay, the mud is here lah. Okay, and then lake, you have the water. So the air escape from the mud, right? Correct. And then it comes out as small, tiny bubble, but then it gets bigger and bigger and bigger because the pressure is high here. When the pressure is higher, imagine, okay, the pressure is acting on the bubble everywhere. Okay, very high pressure. As the bubble rises up, the pressure is lower, isn't it? As compared to deep down at the bottom. So the pressure becomes lesser and lesser and lesser. So the pressure that is acting all around this bubble is also weaker. Or shall I say, lesser pressure. You understand? So lesser pressure, it doesn't like force the bubble to become very small. Right? When the pressure is high, the bubble is very, very, very small. So you're right, Anaki. Okay. Why don't I talk about atmospheric pressure?
That is like on the surface.
Yes, very good. When let's say you are talking about something in the surrounding, okay, where there is air surrounding it, then we refer to atmospheric pressure. When you are inside the water, then we talk about the water pressure.
Ma'am, it's the same question. We can
Yeah.
see
It's the same question, right?
it's the same question. It's
Just that Now they put the statement right at the bottom.